Aloha, my name is Anastacio Dalde. Let's study some calculus, and this is Laurel Springs Schools.
Alright, so here's my welcome page. This is, we're going to be talking about calculus, and again, I'm Anastacio Dalde. Let's get to it. So a little bit about myself. I'm a physicist. I work with the Non-Ionizing Radiation Division. Yes, our abbreviation is NERDS, and officially I'm a nerd. For the Department of Defense, I work in Aberdeen Proving Ground in Maryland. I'm a laser physicist. I also have an education in physics. I have a master's in physics from the University of Hawaii. I have a post-baccalaureate certificate of secondary education in science education from the University of Hawaii. And I also have a bachelor's in physics from the University of California at Berkeley. A little bit more about myself. I've spent the last 12 years full-time as a science/math teacher, and 6 of those years was online in a school called Myron B. Thompson Academy. We're a public charter school. And some personal things about me. I was raised in Hawaii. I was born in Pasadena, California, but I was raised all my life in Hawaii. My wife and my kids, they were all born and raised in Hawaii. I have 4 kids and a beautiful wife. If you only see 4 or 3 kids in that picture, it's because the 4th one is on its way. And I love music. I play the ukulele and the trombone and the bass guitar and the guitar, and I've played in bands and rock bands and classical bands and symphonic bands and all of those kinds of things. That's just my passion. So, what interests me about this position? First, I've been bitten by what I call the teaching bug. I have a passion for students and helping them thrive, and I thrive on helping them to succeed. That's where I get a lot of my reward from. I seek out and try to cultivate untapped human potential that a student has within themselves, and being able to kind of be a part of that, man, that is something near and dear to my heart. And so that's why I would like to still continue to teach, even though I'm working as a physicist and doing all these other things. I still want to be able to feed that bug or scratch that itch. The other thing is, I will always be an online teacher, and the reason is because it's an opportunity for me to be a pioneer in my industry. I've been asked by many schools to come and teach for them, and it's that old brick and mortar style school, and I've done that for a long time, but since I've been an online teacher, I really enjoy being one of the only or first or quite often the best techniques of teaching in an online environment, and I'm developing them because there's not a whole lot of people doing that in math education and physics education and science education. And so that really excites me about teaching online. What characteristics make me a strong candidate? Well, I've taken a great many math courses for teaching a calculus course or any math course in an online school. I've also taught many math courses, and I use the best hardware and software for teaching online. Let me talk to you a little bit about it. So the math courses I've taken, I have a exhaustive list, and I didn't want to list it all out here because you don't want to see a big wall of text, but some of the math courses I've taken is 307, linear algebra with differential equations. I've also taken an introduction to advanced mathematics where we did a lot of like abstract algebra. I've done elementary probability theory, mathematical methods for a theoretical physicist. That's a 600 level course. I've done partial differential equations and all of the different calculuses. Some of the math courses that I've taught include like 6th grade mathematics, middle school mathematics, algebra 1, geometry, algebra 2, pre-calculus, trigonometry, calculus 1, calculus 2. I've taught all the way from elementary school, middle school, high school, and community college. And some trainings that I've had is for 3 years in a row, I've been going to an AP Summer Institute where I've got to spend a week, 2 weeks learning calculus and how to teach AP specific calculus and AP physics and AP chemistry. Some of the hardware that I use, and let's just switch over to discussion. There we go. Some of the hardware that I use is my favorite. I mentioned how I use good hardware and software. This thing is worth its weight in gold. This is the Blue microphone. I love, and every single math teacher who teaches online needs to have something like this. Here's my X200. It's one of those tablet computers with a pen. In fact, you guys are wondering, like, how is he showing this, and that's the computer he uses? Well, actually, I have two of them. I have two of these computers where I have tablets on them, and I can use them to write directly on them. I'm going to show you that in my little quick lesson. And some of the software that I've used Canvas, I've used Wimba and Blackboard, and I've also used Adobe Connect for the last like 3 years, and I've used WebEx with Cisco. So I've used a wide variety in the 6 years of being an online teacher. I've learned a whole bunch of different programs and softwares, and I'm keeping up to date with even Python programming. And all of these things really add to my tool set of being an online teacher. All right, so let's get into my 10-minute lesson. What we're going to do is we're going to talk about the definition of a derivative. The definition of a derivative, f prime x, is equal to the limit as h goes to 0 of f of x plus h minus f of x, all divided by h. Or f prime of x can also be thought of as f of x minus f of a, all divided by x minus a, and this would be the limit as x goes to a. Now, the derivative is the core of of calculus, and it's one of the cores of modern mathematics. But the formula can be very scary and intimidating. And you know what's not intimidating? What's not intimidating is slope. You know, the thing we learned back in Algebra 2. The slope is simply rise over run, which basically is telling you the change in y divided by the change in x, or y2 minus y1 over x2 minus x1. And that would be the angle that one would see if they were to connect two dots. And you need two dots to make a line. So then you connect those two dots and you would kind of see the angle or the slope, or how fast the thing is increasing as it goes across. Applying this to the real world, this is the concept of speed. For example, if I were going at, let's see, at time is 8 o'clock and now I have 10 o'clock, and over here I have a distance of 5 and a distance of 12 up here. In that case, I'm going, what is that? Or I'm sorry, I put 125. So in that case, I'm going 120 miles, 120 miles in 2 hours. And so that's 60 miles per hour. Now, this would be great if everything traveled at the same speed and nothing ever changed the speed. The problem is that's not how the real world works. Take a ball and throw it up in the air. Watch its motion. If I were to graph, and if you were to throw a ball straight up in the air and then have it land back in your hand, if I were to graph the height versus time, it would look like this. Now, I know it didn't literally look like that. Maybe it went straight up and down, but remember, this is not a distance horizontal axis. This is a time horizontal axis. Here's the thing. How would you find the slope of a curvy line? Well, the first thing we need to do is define what a slope of a curvy line is. And what we mean by that is let's say that we want the slope of a particular point or a particular point on the curve, and we want to find the slope of a line that is kind of touching only at one point. Now, the old Latin word tangene means to touch or touching, and so we named this thing a tangent. So a tangent would be a point, or a line that only touches at one point on a curve. Now, herein lies another problem that we have. The tangent line is defined by only one point. Now, if I were to ask you, draw a line that goes through that point, you wouldn't be able to do it. You would have to say, you would say, well, I could draw this line. And then I would say, no, that's not the line I was thinking of. I was thinking of this line. And you would say, well, that's not fair because you only gave me 1 point. In order to draw a line, you need 2 points. So we can't just have this tangent thing and actually have a defined line. How do we even define a line that does that? So here's kind of what we're going to try to do. Got a wire that I bent. And let's say that this curvy, ugly looking thing represents our function. And I have a bead on that wire. Now, I want to find the tangent line that is tangent to this point right here. But I don't have 2 points. So what I could do is I can just get another bead, and now I have 2 points. And as I can find the slope between this point and this point right here. And notice that as I move this bead closer and closer to that first point, the tangent, the slope, the second line that I'm creating, matches more and more with that tangent line that I was talking about. And as I get this thing incredibly close, it almost becomes identical. In fact, if I could somehow make it so that the distance between those 2 beads was almost 0, then those tangent lines would match identically, exactly the same. All right, let's switch back to the tablet so I can show you what I'm talking about. All right, so check this out. What we have here is we have some curve like this, okay? And we want to find the tangent line that looks like this. Now, this x coordinate right here, we will call A, because that's the point we're interested in. And this right here, which is normally f of x, we're going to call, well, at this height, it's f of A. Because the height of this point right here is, well, whatever A is, and you just plug that in over here. Because this is your x values, and that's your A value. Now, that second bead that we're talking about is, say, right here. And the x value is right here, and then the y value would be f of x. Because this is the x value, and then that's the associated f of x. Now, in order to find the slope of a line that connects this dot to that second dot, we would simply do rise over run, which is f of x minus f of a, all divided by x minus a. And then what we would do is we would want to move that second bead closer and closer to the first bead. We want to move x closer to a, and that's why we say we're going to take the limit as x goes to a. Now, some of you are asking, oh, well, some of you are saying, wait a second, that looks familiar. That's exactly what that definition is. So there, we're not pulling equations out of thin air. These equations make sense. They come from somewhere. And this really is just slope, the definition of slope. Now, what is this h thing all about? Well, let me explain to you. Remember how I said, if I could somehow make the distance between the two go to 0, then they would be identical. Okay, it's a little weird to define the limit of something as x goes to a, But what I could do is I could say, this point right here, let's call it x now. And so this is f of x. And then this point right here, or let's call this distance h. It's the distance between the second point and the first point. So this second point is no longer sitting at x because that first point is sitting at x. This guy's sitting at x plus h. So his height is f of x plus h. Okay, well, the definition of the slope is f of x plus h. That would be the height of the second point minus f of x, the height of the first point, divided by x plus h minus x. And x plus h minus x, well, I'm going to combine like terms, and those guys cancel. And so that's exactly what I'm left with. F of x plus h minus f of x, all divided by h. And you're taking the limit as h goes to 0. Now, you want to see this in action. You want to see this applied. And I don't have time to do that, but what I really wanted to explain to you is equations that us math teachers give you. Even though it may seem like magic, they don't come out of thin air. They come from someplace, and it might even be someplace you're quite familiar with. And that's what I'm really passionate about doing, is trying to show you and debunk all of these crazy things about math, so that way you understand where things come from. I hope that helps.